The story is then that these huge monolithic stones come to life, and these levitating rocks are what helped build Machu Picchu in the first place. Perhaps the greatest indication that there was some association with ancient aliens.
Earthquakes, landslides, and relentless rain have destroyed countless mountainside settlements in the Andes. Yet Machu Picchu has endured for centuries, its walls and terraces remarkably intact. When archaeologists finally turned to modern scans to see beneath the surface, the results were shocking.
Look at that. These terraces, it almost looks like a bunch of little buildings.
Hidden structures revealed an engineering precision that seemed impossible for a civilization without advanced tools.
The radar indicates a huge amount of metal down there. Gold, exactly the kind of riches.
What they discovered challenges everything we thought we knew about ancient construction.
What we don't see is that 60% is underground. It's absolutely breathtaking.
A perched wonder in the Andes. Machu Picchu sits high in the Peruvian Andes at about 8,000 feet above sea level.
How do you do it at the top of a mountain?
It was built along a narrow mountain ridge with steep drops on both sides. Most ancient cities were placed on plains, near rivers, or on broad hills where the ground offered natural stability. Machu Picchu was positioned on a thin spine of stone where a single failure could send structures sliding into the valley below. From the very beginning, its position forces a serious question. Why would anyone choose to build here? From a distance, the site appears calm and carefully ordered. Long stone terraces descend the mountainside in clean, horizontal bands. Open spaces separate tightly fitted walls. Everything about the layout suggests control and intention. Yet this surface impression hides the true nature of the terrain. The slopes beneath the city are sharp and uneven. In several places, the ground drops almost straight down. The setting offers no natural forgiveness. Any weakness in construction would have been amplified by the slope itself. Machu Picchu covers roughly 12 acres of this extreme terrain. There was no flat ground available for use. Every level surface had to be created by shaping the mountainside itself. Terraces were not decorative features, but structural necessities. Each one had to be precisely measured, reinforced, and locked into the slope. Stones could not be placed casually. If a wall leaned or soil shifted, the failure would not remain isolated. It would move downward, destabilizing everything below it. The danger does not come from slope alone. Machu Picchu lies in a region known for frequent earthquakes. The Andes are under constant geological pressure, and tremors are a recurring reality. Added to this is heavy rainfall throughout much of the year. Water penetrates the soil, increases weight, and weakens the ground holding stone in place. Landslides are common in surrounding areas, and historical records show repeated slope failures nearby. Every major force that threatens stone construction exists here at once. Many ancient sites exposed to far less stress have cracked, shifted, or disappeared entirely. Machu Picchu does not follow that pattern. Its walls remain straight. Its terraces continue to hold their form. Large sections appear unusually intact for their age. This survival has unsettled researchers.
It's a masterpiece of Incan engineering in terms of how precisely it controls the water.
What remains visible is careful stonework and ordered space, but those features alone cannot explain long-term stability in such conditions. While the view above captures attention, recent investigations have focused on what lies beneath the surface. Modern technology has begun to reveal answers that are far more unsettling than the landscape itself. Modern scans reveal hidden engineering. For most of modern research history, Machu Picchu was studied only at what could be seen. Archaeologists documented walls, stairways, and terraces. Engineers inspected cracks and surface damage caused by rain and age. Everything beneath the stone was left untouched, not because it lacked importance, but because digging risked damaging the site. Without a safe way to look underground, the interior of the mountain remained a blind spot. That situation changed when non-invasive scanning tools became available. According to research teams involved in recent studies, Ground-penetrating radar, three-dimensional laser scans, drone imaging, and artificial intelligence analysis were introduced to evaluate erosion and long-term stability. The goal was practical, not historical. Authorities wanted to know which parts of the site were at risk of collapse due to rainfall, earthquakes, and growing tourist pressure. The first scan results were unexpected. Instead of showing random layers of soil and rock, the data revealed large underground zones made of stacked materials arranged in clear patterns.
When I went to Machu Picchu in 2017, what's very interesting is I saw evidence of ancient structures underneath what's there now.
These layers were not natural. Natural soil settles unevenly, but the scans showed repeated sequences that were evenly distributed across the site. According to reports, these patterns appeared beneath nearly every major terrace. As researchers widened the scan area, the scale of the discovery became clear. The terraces were not separate structures built one at a time. They were physically linked beneath the surface. What appeared above ground as individual platforms were part of one continuous internal system that ran through the mountain. Areas once assumed to be solid bedrock turned out to be engineered fill made of carefully selected materials. This changed how the visible city was understood. The stone walls that people see are only the outer shell. In some sections, scans showed that the visible masonry represents a small fraction of the total construction effort. Beneath each terrace lies a deep, internal structure that supports weight, manages pressure, and stabilizes the slope. According to some estimates, more than half of the construction work is hidden underground. When engineers attempted to analyze this system using modern software, they encountered problems. Reported findings suggest that standard engineering models could not easily explain how the internal structure distributes stress. The system appeared intentional, but it did not follow familiar modern design rules. Simulations based on common assumptions produced unstable results, even though the real structure has remained stable for centuries. More questions emerged as researchers examined the consistency of the underground features. Certain patterns repeated across different sections of the site, even where terrain conditions changed. This suggests planning rather than improvisation. Yet there are no surviving written records describing how such a system was designed. Some researchers believe this points to advanced practical knowledge passed through experience rather than formal documentation. Others urge caution, noting that the absence of written records does not mean the knowledge was unusual for its time. This discovery changed the direction of research entirely. Machu Picchu was no longer just a question of architecture or symbolism. It became a problem of engineering on a massive scale. The scans revealed deliberate construction beneath the terraces, but understanding the design required examining how each terrace was built, layer by layer. Terrace architecture. Layered engineering. Machu Picchu's terraces are not just simple steps on a mountainside. According to reports from recent surveys and studies, each terrace is a carefully designed, multi-layered structure built to perform multiple functions simultaneously. The first layer consists of massive foundation stones. The foundation stones were positioned to resist the lateral pressure of the soil and rock behind them. According to studies conducted by civil engineers visiting the site, this layer alone provides a remarkable amount of structural support. Even under the weight of upper layers and the forces of gravity on a steep slope, these stones hold fast. Above the foundation stones lies a secondary layer of smaller rocks and gravel. Researchers have noted that the stones are carefully graded and arranged to create a solid base for the upper layers. This layer serves as a buffer, distributing weight evenly across the terrace and preventing the foundation from shifting. According to local reports, the precision with which the stones were selected and placed is comparable to techniques used in modern construction projects. The consistency across hundreds of terraces is particularly astonishing. The next layer consists of sand. According to some researchers, this layer functions as a compacted buffer that absorbs small shifts in the underlying foundation and keeps the soil above from compressing too unevenly. It is subtle, yet critical. Without this layer, the upper portions of the terraces would be more vulnerable to collapse or uneven settling. Observers have remarked that the combination of foundation stones, gravel, and sand represents an understanding of stability that is not explained by surviving records of Inca engineering. On top of this, a layer of rich topsoil was added to allow crops to grow. The soil layer itself is leveled and maintained across all 700 terraces. Archaeological reports indicate that the uniformity is striking, given the extreme slopes and variable terrain. Every terrace was built to the same specifications, even though the natural contours of the mountainside are wildly irregular. Some researchers have speculated that the builders followed a master plan, rather than creating terraces individually in response to local conditions. The scale of the terraces is staggering. More than 700 terraces cover roughly 12 acres. Each one mirrors the specifications of the others. According to reports, no modern construction project could match the uniformity and precision across such a complex landscape without advanced surveying tools.
Stones fit together perfectly without any mortar. It's almost like a jigsaw puzzle. They did not have the advanced technology that we have today, so it's really a marvel.
The repetition, scale, and exactness suggest deliberate planning and an understanding of materials, weight distribution, and slope management far beyond what is commonly attributed to the Inca. This layered engineering demonstrates that Machu Picchu was not built by trial and error. It required foresight, coordination, and knowledge of how different materials interact under extreme conditions. Every terrace, every stone, every layer plays a role in creating long-term stability. According to some researchers, the terraces themselves may be the single most important factor in keeping the site intact for centuries. Understanding this structural design raises the next question. If the terraces are engineered with such precision and planning, what exactly were they protecting? The answer lies in the force that threatened the site more than any other. That force is water. Water mastery, a hyper-engineered drainage system. Machu Picchu's builders faced a monumental challenge. Heavy water running down steep slopes could easily wash away soil, destabilize terraces, and destroy walls. According to reports from researchers studying the site, controlling water was not optional. It was essential to the survival of the city. The terraces themselves were the first line of defense. They were carefully angled and layered so that water never lingered on the surface. Instead of flowing randomly and causing erosion, rain was absorbed and guided downward in a controlled manner. According to unverified reports, the terraces were designed to work together as a system, with each level channeling water to the next in a deliberate sequence. Nothing was left to chance. Beneath the visible stonework lies an invisible network. Researchers using ground-penetrating radar have identified layers of gravel, stones, and sand beneath every terrace. According to published studies, this combination filters water as it moves downward, allowing it to pass through the terraces without carrying away soil. Some engineers studying the site have said that the precision and consistency of this layering surpass many modern drainage projects. The system is not uniform. It adapts to the slope, the type of rock beneath, and the expected water load. Beyond the terraces, there are underground channels carved directly into the bedrock. According to several sources, these channels collect excess water and redirect it away from the foundations of the terraces. The channels are carefully angled so water flows steadily, never pooling in one location. Experts have reported that even during the heaviest storms, water is dispersed across the mountainside rather than concentrated in dangerous areas. The result is that landslides and soil collapse, which are constant threats in the Andes, are largely prevented. The system is dynamic. In some areas, channels are wider or deeper to handle greater water pressure. In others, gravel and sand layers were modified to control flow rates. According to unverified reports, this shows an understanding of hydrology and site-specific adaptation that is extraordinary for the pre-Columbian world. The builders observed the mountain carefully and adjusted the design to match natural conditions. Modern simulations have tested the terraces and drainage channels. Researchers report that the system manages volumes of rainfall that overwhelm many contemporary urban drainage networks. Even in extreme storms, water moves safely through the terraces without destroying the structures. Some engineers studying the site have described the drainage system as the most advanced water management design ever documented in the Americas before European contact. This level of control demonstrates more than engineering skill. According to reports, it required coordination, careful planning, and immense human effort. Each stone, layer, and channel had to be positioned exactly as intended. Misplacing even a single element could compromise the system. The builders not only mastered the natural flow of water, but also mastered the challenge of organizing hundreds of workers to achieve this feat across a complex and dangerous mountainside. If water could be managed with such precision, the next challenge was even greater. The mountain itself was unstable. Terraces could survive rain, but could they survive the forces of earthquakes? That question shifts the focus from water to the movement of the earth beneath the site. Terraces that absorb earthquakes. As the archaeologists continued their investigation, they brought in Dr. Emilio Vargas, a structural engineer specializing in seismic behavior in mountainous regions. Dr. Vargas had studied hillside construction and earthquake mechanics for decades, but even he admitted that what the scans showed at Machu Picchu was extraordinary. The terraces are designed to absorb seismic energy. Each stone wall is not rigid. Instead, the stones shift ever so slightly when the ground moves. Gaps between stones, often just a few millimeters wide, allow them to move independently. During tremors, these tiny movements dissipate energy that would otherwise crack or topple the structures. The terraces act together, forming a flexible system that stabilizes the entire mountainside. The effect is astonishing. Computer models simulate earthquakes of a magnitude that would destroy most modern hillside cities. Machu Picchu's terraces shift imperceptibly, distributing stress across hundreds of walls and terraces. The movement is subtle, almost invisible, yet the impact is monumental. What would demolish other sites leaves this city intact. Dr. Vargas reported that the terraces behave in ways similar to modern reinforced concrete buildings with base isolation systems. The remarkable part is that this system was built centuries before seismic engineering was formally understood. Experts repeatedly confirmed the results but remained baffled by the precision. There are no written records or manuals describing these construction methods. Every wall, terrace, and layer of stone performs exactly as needed to survive tremors. Researchers describe the system as silent and self-regulating, functioning automatically without maintenance. Dr. Vargas admitted that he had never encountered anything remotely comparable in hillside construction anywhere in the world. The scale of the achievement is staggering. These terraces are not isolated. They operate as a coordinated network. When one section shifts, the force is transmitted in a controlled way to neighboring terraces. The energy of the mountain is absorbed and redirected, preventing catastrophic collapse. Some engineers expressed disbelief, noting that even with modern tools, reproducing this system would be nearly impossible. The combination of observation, knowledge, and labor required is beyond comprehension. This revelation forces a new perspective on the construction of Machu Picchu. The survival of the terraces is not the result of chance. Every stone contributes to a system capable of withstanding forces that would destroy ordinary construction. The question becomes unavoidable. If the builders could create a system that controls the movement of an entire mountainside, what kind of human effort and planning went into placing those stones? The seismic mastery of Machu Picchu raises a pressing question. How could such precise, structured engineering exist in a place of such scale and difficulty? With massive stones and a mountainside that defies construction? Answering that leads directly to the human challenge. Moving, shaping, and placing these enormous stones required effort, coordination, and skill, an achievement that brings the scale of human labor at Machu Picchu into sharp focus. Logistics and the human challenge. The scale of human effort behind Machu Picchu is staggering. Every stone used in the terraces and walls had to be moved from quarries located 2 to 4 kilometers away, often across steep, uneven slopes. Some of these stones weigh up to 1,000 pounds. Moving them without modern machinery would have required immense physical strength, careful coordination, and ingenious techniques to prevent injury or catastrophic mistakes. According to estimates, the terraces alone contain roughly 60,000 tons of cut stone and fill material. Each piece had to be precisely positioned to fit into the larger structure. Modern simulations attempting to model construction suggest that even under ideal conditions, 1,500 workers would require 15 years of continuous labor to complete the site. This assumes optimal organization and no delays, yet in reality, the builders faced extreme environmental challenges. Machu Picchu sits at 8,000 feet above sea level. The high altitude reduces stamina and increases fatigue. Workers also contended with rainfall for more than 200 days each year. Slopes became slippery and dangerous, increasing the risk of landslides or accidents.
When there is a heavy rain, the water needs to be evacuated, otherwise Machu Picchu could collapse. That's why the Incas constructed the drainage water system underground.
The landscape presented additional obstacles. The Urubamba River, which snakes through the valley below, is not a gentle stream. In sections, it has Class 4 rapids. Transporting stones, tools, and other materials required crossing treacherous terrain. Even with the knowledge and skill to manipulate large stones, workers had to manage the risk of falling or losing critical materials into the river. According to some researchers, many foundation stones were placed in trenches 6 to 8 feet deep. Once positioned, they were buried beneath layers of soil and gravel, forming the base of the terraces. Any misplacement could have destabilized the terraces above, causing a chain reaction of collapse. The physical feat alone is almost unimaginable. Teams had to lift, slide, and leverage stones while maintaining precise alignment. They needed to work in perfect coordination across multiple terraces simultaneously. Reports from modern engineers emphasize that reproducing this effort today would require heavy machinery and detailed project management. Yet the builders achieved this entirely through human labor, observation, and ingenuity. Environmental challenges compounded the difficulty. Torrential rains could turn slopes into mudslides in minutes. Workers had to adjust quickly, stabilize the site, and continue labor without delaying construction. Seasonal variations in temperature and weather added another layer of complexity. Each task required not only strength, but foresight, planning, and adaptability. According to some studies, the builder's ability to manipulate such a hostile environment shows an extraordinary understanding of both the mountain and its resources. The logistical and human challenges of constructing Machu Picchu emphasize more than just the physical labor. They reveal the remarkable coordination, leadership, and problem-solving capabilities of the people who undertook this task. Every terrace, wall, and stone reflects planning at a scale that seems impossible for its time. Once the human capacity to organize and execute such a monumental project is understood, the next question emerges naturally. Who were these people? And how were they capable of making structures that combine enormous strength, precision, and resilience? The impossible knowledge. Who really built Machu Picchu? For centuries, Machu Picchu has been the subject of astonishing rumors and myths. Some local stories claim that the terraces and walls were built with guidance from the gods, explaining how the structures could endure landslides, tremors, and centuries of weather without collapsing. Others suggest that extraterrestrial beings played a role, bringing advanced knowledge that allowed the city to be constructed with precision far beyond human capability. There are even tales that half-human, half-horse creatures labored on the site, combining extraordinary strength and intelligence to move massive stones across impossible slopes. None of these accounts are verified, yet the extraordinary engineering of Machu Picchu makes such stories persist. Buried terraces and hidden chambers add fuel to the mystery.
In many Incan cities, the Hanan or Upper District is where you find the most spectacular monuments. The Hurin district was much more working class, let's say. It reveals a certain view of the world.
Some archaeologists report evidence of older construction phases that predate the 15th century. According to certain accounts, these underlying structures may have served as foundations for the visible city. Travelers during the colonial era noted stones placed with such precision that they seemed impossible to move or fit using human strength alone. The combination of rumors, ancient accounts, and visible engineering creates an aura of the impossible that has fascinated researchers for generations. Modern studies have brought new insight, though they raise further questions. According to recent AI analyses, Machu Picchu contains 47 distinct construction techniques, many of which are not seen elsewhere in the Andes. Experts report that the alignment of stones, the precise layering of terraces, and the integration of structural elements solve complex engineering challenges on the first attempt. Some engineers describe the results as statistically improbable for humans working with the tools known at the time. The terraces, walls, and underlying systems appear to function as a single, coordinated framework, with precision that continues to astonish researchers. Archaeologists suggest that the city may have been built in phases. Some evidence indicates that earlier builders laid down the foundations and portions of the terraces. According to reports, the Inca, arriving later, may have inherited these structures and expanded them into the city that exists today. Oral traditions among local communities support this idea, implying that the Inca were aware of pre-existing engineering knowledge and used it to their advantage while adding their own innovations. Despite these questions, mainstream archaeology attributes the construction of Machu Picchu to the Inca under Emperor Pachacuti. Historical records indicate that Pachacuti commissioned the site as a royal estate and ceremonial center. Archaeologists emphasize that the Inca displayed extraordinary planning, organization, and labor management to execute the construction on such a steep mountainside, transporting massive stones and coordinating hundreds of workers without written engineering plans. The combination of myth, inherited knowledge, and precise execution leaves a puzzle that continues to challenge researchers. The terrace's durability, the perfect alignment of walls, and the hidden engineering systems all suggest an understanding of geology, materials, and seismic forces far beyond what is documented elsewhere. Machu Picchu remains a monument to extraordinary skill. Rumors, legends, and scientific findings converge on one undeniable truth. The city reflects knowledge and mastery that seems almost impossible to reproduce, even by modern standards. If you enjoyed watching this video, kindly hit the like button and subscribe to this channel. Thanks for watching. See you in the next one.